So now I've got just kind of an assortment of miscellaneous slides. So for instance, the term cloudburst talks about kind of a cloud dumping its precipitation and then going on about its business, kind of a short-lived sort of precipitation event. On the next slide, I'm going to kind of give you an assortment of precipitation. By definition, precipitation has to fall from the atmosphere and hit the earth, basically. So dew and frost are not forms of precipitation. Verga is a term that I think you have in a homework question for Chapter 5, and sometimes you see it on the test, wink, wink. But Verga basically is precipitation will fall from a cloud, but the air that the precipitation is falling into is so dry that basically it evaporates, that falling precipitation evaporates before it reaches the ground. Isn't that cool? I like Verga. Oh, sorry. And back here, this, I don't know if you see this picture down here, but that's a slide, that's showing you Verga, where can you see kind of the drippiness of the precipitation, but it doesn't reach the ground. Here is a good table of various types of precipitation. Mist, drizzle, rain, sleet, freezing rain. Rime is coming up. Rime is just kind of like thick frost as far as I can tell. Snow. We're going to talk about hail in a minute because remember I haven't talked about hail yet, and grapple kind of goes along with hail. So snow, here's some miscellaneous things about snow. I mentioned that actually it's true. I believe that all snowflakes are unique. They take on a 6-sided shape, and that has to do with on a molecular level how those Mickey Mouse water molecules kind of connect each other with those intermolecular bonds. So that's kind of fun. All right, and another thing about snow I mentioned before is that the temperature that the Bergeron process is occurring at will give you different crystalline shapes. So that's kind of neat. Aren't they beautiful? So hopefully you're okay with sleet, which is basically little ice globules that have refreezed after melting, after being solid snow crystals. So hope that all works for you. But so sleet and freezing rain, what they both need is basically a pocket of cold air here. And we're going to, when we talk in a later chapter about fronts where air masses collide, that's kind of what's being shown here. You have an air sector on the right, that's cold air, and you have an air sector on the left, that's warm air. One of the things we're going to find out when chunks of air like this meet, cold and warm, is that the cold air is more dense and the warm air is lighter. And so actually what's being shown here is a bit of what we call overrunning, where the warm air is running up and over the cold air. And so related to that then, you can get this stubborn cold air at the ground, and so there you basically have a temperature inversion. You have that pocket of cold air here at the ground. And so shown here then is we have snow up above, normal temperature, no temperature inversion to here. It goes ahead and melts and forms rain, and then it has that cold pocket of air, and it refreezes. In this case, it has enough time to go ahead and solidify in the case of ice pellets or sleet. All right, miscellaneous about precipitation. Hail. Now, hail comes only from, I want to say only, from a cloud, cumulonimbus clouds. There's going to be a whole chapter on severe weather, and severe weather is associated with cumulonimbus clouds. Cumulo meaning fluffy, unstable, nimbus meaning precipitating. So the thing about cumulonimbus clouds, and you're going to see it on the next slide, is that there is a fair bit of chaos going on inside. It's chaos, but it's kind of ordered chaos. There is an updraft and a downdraft, and actually it's kind of that updraft and that downdraft that gives us a charge separation, that gives us our lightning, and it's also that updraft and downdraft that can give us some sort of rotation that can give us a tornado, and it's that updraft and downdraft that gives us these balls that we call hail. So hail only comes, I know it looks like sleet a little bit, but hail only comes from cumulonimbus clouds, and it's a different phenomenon. So can you see kind of the updraft down here? This is a cumulonimbus cloud here. Can you see the updraft is in red and the downdraft is in blue? And you kind of see this, I'll show you this, I don't know if you can make out the kind of this purple going up and down. But basically what we have within this cumulonimbus cloud is the top of the cumulonimbus cloud, it's a cool cloud because we have freezing temperatures, and the bottom of the cumulonimbus cloud we have temperatures that are warmer than freezing. So what happens is these cute little pebbles called grapple actually kind of start the process. So it's a little nubbin, solid water, and it kind of, you can kind of see the path. It goes up and down and up and down. And as it goes down, it kind of melts and gets all soggy and liquidy. And as it goes up, remember, grapple is a solid piece of ice, of water, and as it goes up, it solidifies and it can pick up more, it can grow larger with regard to its solid parts. So it kind of goes up and down and up and down. And each time it goes up and down, it gets larger. So one of the things about, if you see this kind of, the guy holding the hailstone, is that it ends up kind of being like an onion shape, where the center of the onion would be the oldest part of the hailstone, okay? And the last added would be the outer part. So we talked about terminal velocities, and the terminal velocities of these things can be pretty outstanding. So for instance, you see a relatively, 3 centimeters, that's a little over an inch, okay, hailstone. It will max out its falling speed at about 77 miles per hour. So that's why our cars get dented so much. But these hailstones only fall from cumulonimbus clouds. And not all thunderstorms bring hail. But it'll form in kind of, do you see the downdraft there? It'll be part of the downdraft portion. Updraft, downdraft. There's the guy in his cars. It's classic. Rime is just like kind of thick frost. Doesn't look like thick frost to you. So I think I've seen rime before, and it's a rime event. It's very pretty.